Okay, let's start the session we we have everybody here, and today's session will drag a little longer. So we hope to finish it within 45 minutes. Let's see how it goes.
So this is a brief introduction about me. I'm Aravind Ratnayaka and I'm currently working under BU2 for the Big Data and Data Science platform. So it is all about object advance, and previously we have done about what are the basics, fundamentals of objects. So for some of newcomers are here for the object advance session. So you would like to know what are the previous session, what are we did. So let's revise, let's take a little more time. So first of all, in the sixth session, we have first introduct about the what are the basic objects of JavaScript. So JavaScript object is basically a real object that are similar to a real object. So the same real world scenario is applicable in here, but in the newcomers, just like coming from the OOP, they have get a bit more confused about the how those objects are created, how the things are happening on JavaScript. So in the second, in the sixth session, we have tell about how we can define an object. So there is 4 ways of defining an object. So we can use object initializers. We can define an object using just assigning a constant or let keyword as a literal. So we can use function constructor for creating, and we can use the JavaScript is providing a native function for create objects. So there was another thing called we can use ES6 class also. So people who are coming from the OOP to the JavaScript, they can use ES6 classes, but actually JavaScript is a prototypal based language. So everything is built on top of prototypes. So we have briefly discussed about what are the accessing methods and defining methods of the JavaScript objects. So we can use dot operator and the expression for the accessing the properties on objects. So basic abouts, we have discussed about the basic abouts, what are the objects and its prototypal inheritance. So those are the basics things we have learned so far in the object session. So let's discuss about what is the object prototype. So basically people are working with JavaScript. People have working JavaScript project. Can you answer what was the output of this code? Can anybody answer?
It's a simple question, right? Anybody? No clue?
Okay, let's go ahead. So output is woo. So basically, if we create in the, I will explain the code level. So first of all we have defined a puppy function, and it has 3 parameters. So those are initialized to the initialized to the properties called name, breed, and is assignated. So afterwards, we have assigned assign a property to the puppy prototype called Woof. So after that, we have created the new puppy and pass the values on it and take the reference of puppy object. And if we after that we have using the dot operator, we have print the value on bark, so that will print. So how did it happen? So basically, if so we will discuss in the later. We have a hierarchy design for how it goes happen. So you have to keep remember when we come to the browser level, there is no we can access primitive values using double underscore prototype proto. So it will hold all the parent level properties on proto.
Okay, let me explain a bit further on this. So, what has happened is now here we have created a new instance of the function in function constructor which we have created called puppy. So we have instantiated that and created an object out of it called puppy object, and on that object we have called the we have actually tried to access bark keyword, bark property. So that is again in the property, and this underscore proto underscore that particular property is actually what's represented in the browser when you try to debug and see this. So actually what's happening is, even though you write this code this way, when you execute it in the browser, if you have worked with JavaScript, you might have seen that whenever you are debugging and trying to analyze or trying to see whatever the internals of objects, say if you try to put a debug point, and if you try to see what all properties are available in object, then you can see that there is something called underscore proto underscore. In Chrome or Firefox, you might have seen this. So the same prototype over here, whatever you define in the prototype will go into that particular keywords, whatever the properties. So in browser, they use this particular property to represent the same prototype. It is nothing different from prototype, same thing is there, and whatever the concept applies for prototype applies for this one, and different browsers use these kind of different keywords or whatever the property whole properties with different names to imply the same thing. So just keep in mind, if you try to debug and see in whatever the browser to see what all properties are available in the prototype, then you will see something like this, not the actual prototype. But it depends on the browser also. So in IE, it works in a bit different manner. If you take a look at all the browsers, all IE browsers, but new browsers, again, this is kind of like a defector. But never try to assign, no, mutate or do anything with this underscore proto underscore property in your code. Always access prototype with prototype keyword. Don't use anything else.
So that's all about prototype introduction. So here is another example for using. We have used two functions. One was animal, and the another one was dog. So
so actually, these are function constructors, right? We have two function constructors here.
Okay. Then first of all, there are three diagrams. So one was used to call make sound.
Yeah. Before even going into that detail, hope you all can understand what we have done here. So we have animal constructor, and there in the prototype we have created a method called sleep in the prototype. So that is clear, right? And in a later line, you can see that we have a dog function constructor, and there in the prototype, we are, first of all, what we are doing is when we create the dog constructor, soon after creating the dog constructor, we use all the prototype methods of animal. Actually, what we are doing is we are creating a new instance of animal, and we use object create method to extend dog with animal. So this is how you do like double OP concepts in double OP concepts inheritance in JavaScript. So if you want to inherit everything from animal to dog uh, in prototype level, what you have to do is you have to use object create keyword, and you can simply set the prototype level values of animal to whatever the target constructor function. So
what is the actual difference of assigning it to prototype property and assigning it to direct property of that?
yeah, so direct property, what will happen is whenever you create an instance, say you create 10 instances of dogs, then all 10 instances of dog will have a different copy of that property if you create it using this keyword, this dot name or something like that.
Yeah.
That will be local to the object created from that particular constructor function. But if you create it in the prototype level, that is common to all 10 objects.
It's like static.
So take it this way. It's more like a common memory reference where you have one variable and everybody can change that same variable. We can use, mainly prototype is used for functions. So why we do this is, say you create a class, and whenever you are creating instances, you don't want to create duplicate functions, right? So say if this particular constructor method associated class has 10 functions, and whenever you create an object, say you want to create 10 objects out of it, for all those 10 objects, you don't want to create 10 copies of that whatever the methods available in that function for each individual object, right? So that is mitigated from this, where you have everything in prototype, and prototype is kind of like one place to keep all the common things, and all the objects will access all those functions from that same reference. So that is the difference. And here we have used simple inheritance. So this is one approach of like emulating inheritance in JavaScript, but there are several other ways. We will discuss in later sessions what all we can do, and there are a whole lot of easier ways. But this is one way. And in the dog prototype, what we have done afterwards is, now we have inherited all the things from animal, and after that we have defined one other function called make sound. And in a later line, you can see that we have created an instance of dog, and we have called two functions, make sound and sleep. So when you do this, what will happen is, now if you take a look at this line, make sound. So make sound is one of the methods available in dog prototype, right? So what happens inside is, once you try to call this function, it will see whether this particular make sound method is available in the dog prototype or dog level properties. So dog level property would be something like this, name. If I try to access name, first of all it will see whether it is available here. If it is a local property, then yeah, if you try to access name, it will directly return the value of it. If it is not there, it will go to the prototype of dog and see whether it is there in the dog's own prototype. So this is dog own prototype, and it will try to see whether it is there. Now make sound is there in the dog's own prototype, right? So then it finds the particular function and it invokes it. So this is that. So this particular part of the diagram explains, first part of the diagram explains, okay, it finds the prototype method, make sound method in prototype, and it executes. And afterwards, in the last line, you can see that we have called sleep. So now if you take a look at dog's prototype, now this is a dog instance, right? And in dog's prototype, we don't have a function called sleep. So where does this sleep come from? It is actually coming from animal. So this animal constructor functions associated prototype has a method called sleep. And what happens is, uh, if this particular method or property cannot be found in the own prototype, it will look up in the parent prototype. So this, if you take a look at this particular dog constructor function associated prototype, it has a parent prototype, which is animal's parent prototype, and it will see whether sleep is there. If it finds a particular method or property, it executes it. So that is again working fine. Say in case if we try to access something like age. Now, if you take a look at this example, we don't have anything called age, right? So what happens is, it will try to see whether it is available in the dog prototype. No. It tries to check whether it is available in the animal prototype. No. Then afterwards, it will try to check whether this is available in object prototype. Every object in JavaScript, whatever the constructor function or anything created in JavaScript related to objects will inherit from object in parent level, and it will try to see whether that particular property is available in object prototype. It is not there, right? Definitely, age is not there. So then it will return undefined. Key takeaway from this is, whenever you try to access a property from this kind of hierarchy, say if it is really deep, and if you are trying to access a value, say a particular property which is not available in the prototype, because this is not strictly typed, right? In this particular object, you can simply say, okay, I want to access ABC, because compile time, there is no such thing called compile time here. You can simply load it in the browser. There won't be any errors thrown. So what it will do is, it will try to keep on going through all the parent prototypes to find this particular property. And at the end, in the object level, in the parent object level only, it will stop. So if there is a huge chain of prototypes there, say you have inherited 3 levels or 4 levels, and again, depending on different complications, say if there is a huge chain, then just to access a particular property, you have to go through all these loops. It's like looping, and again, in JavaScript, accessing a particular property value is costly, because normally in other languages, whatever the class properties are defined in a different manner, where you have a dedicated memory reference to that particular property. But in JavaScript, objects are kind of like dictionaries. You all know dictionaries, right? Dictionary types in other languages. You might have heard, right? If you don't know, it's basically a set of kind of like key value pairs, where you have a set of keys. From any key, you can access the value whenever you give a key. And the way it finds the key is, it enumerate through all those keys and try to seek the particular key. If it is a hash table, if it is hash based, then it will basically go into that particular hash and hash value and then find the value. But this particular operation is costly. It is not like what we do in other languages. So seeking for an undefined or not declared property in JavaScript is costlier. Whenever you are coding or whatever the code you write, try to optimize in that manner also. If you want to do something really costly, say you have a loop of say 1,000 elements, and you want to iterate and get values out of it, and if you are given a problem to optimize the code, then you have to think of all these things. And this is one of the key concepts and core level idea you have to get, because JavaScript classes or anything you get afterwards will have this concept, because JavaScript works on top of prototypes, and even if we have class keywords or anything, it's then again whatever it is, it's represented with prototypes.
So let's talk about the primitive and object referencing. So already you have know about there are 6 type of primitives in JavaScript, and all other things are referred to the object. As we Johan said, so top level of the object is every object top level is object dot prototype. So here are how the constant are, how primitives are stored in memory. So basically, we have bark called it has bark literal. It has a woof, and we have assigned bark to the trace. So basically, there is a keyword called woof inside the bark. So trace copy the wall keyword into the trace and stored in the memory. So that basically literals are primitives are stored in the stack.
So, if I explain in simple terms, now this particular string what you are seeing in Woof, whenever you try to reassign it to a new variable, it copies the value. So basically, the value of Woof value of Woof is assigned to bark in the first line, right? So that is in one memory reference, and when you try to assign it to a different variable, it will create one other variable with a different reference. So those are two different references, but the value is the same.
So another thing is object referencing. So in object referencing, we have a property called bark inside the puppy object, and basically we are taking the reference and store into the memory heap. So the primitive values and the referencing main difference is we are in the primitive values we are storing the value as wall in the memory, and when we are come to the object referencing, we are stored only the memory location inside the memory heap.
So that you all got right.
That was called object referencing. So let's discuss about how we can do the object comparisons. So anybody can answer what was the output of this?
So when you call now there are three code snippets, right? So the first one we have a puppy object and a puppy copy object, two different objects with the same property names and same property values. And in the second code snippet, you can see that puppy object is there and it has a set of properties, and we are assigning it to another variable called puppy copy. And in the third code snippet, what you can see is we are comparing it with triple equal and double equal. This particular syntax of triple equal and double equal, don't think much, it is just comparing. We will explain in detail what all happens in this in a later session on operators. Now here you can see that there are two code snippets, right? When you execute the third snippet for the first one and second one, we want you to guess the answer. What do you think? So if we execute it with the first snippet, what would be the answer? What? True. Okay. Any other answers? Okay, why do you think it is true?
Only comparing the value, right? Not the reference.
Okay.
Not the type.
Okay. Okay. So, all right. And any other answers? Anyone else?
Yes.
Okay. So the answer you gave is wrong. So for the first one, you will get false, false for both the comparisons. The reason is now these two objects are two different references. Objects are stored as references, while primitive values are stored as values. So the exact value is stored whenever you try to compare two different strings, then the value is compared. But if you try to compare two objects, then the object reference is compared. Even though these two objects has the same set of properties and same set of values in it, the object references are compared and they are two different references. But in the second one, what happens is, now whenever you have an object and if you try to assign it to a new variable called puppy copy in this case, and if you try to compare those two are both the variables are pointing to the same memory reference which has the same object. So that is the key difference, and you have to keep this in mind because objects are reference type, and whenever you pass it to a function or wherever, if you do a simple change in the object within the function, that change will get reflected in the parent place wherever you have the variable, and you might not expect it to happen, and it will cause a whole lot of trouble. So be aware, and whenever you are coding, just keep in mind that objects are reference types.
In previous slide, you said that when you assign it like this, it will copy the value to it, right?
Yeah, copy the value if it is a primitive type.
So let's discuss about what was the object enumeration in.
And before even going into this topic, now I said right that objects are represented in JavaScript as dictionaries. So what all characteristics are there in a dictionary? Like you all have worked with dictionaries, right? In other languages, can somebody tell me what are the characteristics? What?
You can't have multiple records in the same key.
Yeah, okay. What else? What all you can do in with a dictionary? What all operations are there available in dictionaries?
Search by key.
What?
Search by key.
Search by key. Okay. What else? Any other key characteristics? Isuru? Any key characteristics of dictionary type in any other language? Any language?
Dictionary types are generally like you have key value class, and so in .NET and other kind of languages you have type safe dictionaries, but then I don't think that applies here. But yeah, you can search by keys.
You can iterate through those, right?
Yeah, there are the typical data structure type functions like push, pop, and peek, and all those things.
Yeah. Okay, cool. So in that context, when it comes to JavaScript, these are enumerable. So I said that JavaScript objects are kind of like dictionaries. So in that case, we should be able to enumerate through the keys and get the values and do certain things, right? So that is possible in JavaScript objects. Whenever you have an object, you can enumerate through the object and get the keys and access the values and do all sorts of stuff. So let's discuss in detail about that.
So for the object looping, we can use for in loop. Basically, in is an operator and there is a for loop.
So object itself is enumerable. So that is the idea. You like whenever you look at an object, think of a dictionary. Then you can get a better idea of how this works. Otherwise, it's confusing, right? How can you like write a for loop on object? Yeah, what is the output of this? Any guesses? This is the simplest question, right? Okay, so you will get all the values of these properties.
So before that, so this was the answer when we executing the code snippet. So what was the C is there is a puppy object, and in the in operator we have to consider property as property in the inside the for loop. The property refers to a string. So it will take a look into the puppy object and check whether the key is available inside the puppy object, and then if it is available, it will console log into the console. So we have used the bracket notation in
So
there.
let me again explain a bit further on this. Now, when you have the puppy keyword, puppy object here, so this will get each of the keys which are enumerable. When we were explaining objects in the earlier session, we said that when you are defining a property, you can specify whether it's enumerable or not if you use object defined property. Otherwise, if you create a simple object literal, those properties are by default enumerable. In that sense, when you do this, in the for loop, for each of the properties of this puppy, all those are enumerable right now, and all of those property names will come here one by one. So first of all, you will get name. It was a breed, is vaccinated, and age. Likewise, you will get all these values. And in the console log, what happens is we have the puppy object, and you can access an object value by a string with this notation. So we are simply using puppy object with square brackets. We are simply saying, okay, give me the property value of this particular property, which is name, breed. Likewise, it will go through all of these and log it to the console. And here, if you take a look at this second code snippet, why do you even have to do this? This works, right? But there is a bit of a tricky part here. Say if this object is inheriting from some other object, or if it has a prototype chain which is referring to so many other objects as parents, so that particular parent again has some other parent inheritance. Likewise, if it has a chain of prototypes, then what will happen is whenever you are iterating through the puppy object, it will go through all the properties of that particular object, and it won't finish there. It will go through all the properties of the parent, and then again it won't stop. It will go through all the parents of properties and on until the object level, unless you do this. So here what we do is we check it with the condition saying whether it is a own property of that particular object, and then try to log it. So that is just to check whether it is in the own property. It is a property of that particular object on its own.
So without using the for in loop, we can use in an optimized way the accessing of attributes. So that was called object.keys. That was a native functionality of the JavaScript.
And these things are possible because objects are dictionaries. So again, object keys, you can do this because in a dictionary you can get the key set, right? In a dictionary you can get the value set. In a dictionary you can get the key value pair set. So likewise you can do all those with objects because they are dictionaries.
So in here what we does is we will in the object.keys we have passed the previous puppy object into the object.keys, and it will gives us all the enumerable properties and as an array. So for the access of the array we have used a for each loop, and we have passed the each one of elements into the as the attribute. So we have printed the all the values on the using the console log. In here we don't the parent in a parent prototype, if there are parent prototype properties are there, this will not be printing here because of object.keys only printing the its object own properties only.
So object on will extract only the keys defined in that object. It won't go through all the parent prototypes.
So here is the again the previous output. So how about if you need to, in the previous using the object.keys, we have accessed the object keys, object property names, and if you need to access the values on the object, each properties, you can use the object.values, and it also gives you the all the enumerable own properties of the object as array. So if you need to go on more further, if you need to get the each entries of the object, you can use the object.entries the same way it was applicable. And can you guess what was the answers of the object.values and the object.entries? We are passing the same object that was passing into the for in loop, a simple puppy object.
One has any idea? Okay, I guess you all know the answer but not answering. So this is what you're gonna get. And here, when you get entries, it will have an array of arrays, and that internal array, inner arrays will contain the key value pairs, and values will give you all the values.
So let's discuss about the immutable objects.
Yeah, before going into detail, you all know what immutability means. Immutable. What is it? Speak up, please. Any idea?
The object doesn't change. Any of the properties of the object will not change.
Okay. And why do we need immutable objects? Do we need immutable objects at all? Have you ever used the immutable object in any other language, and do you know about immutability? Why we have used immutable objects
So
in a
Java
language?
string is immutable, right?
Yeah.
So the memory that you have utilized in the RAM
Yeah.
gets saved because of
How does it get saved?
because when you have two strings with the same value,
Mm-hmm.
you don't create two actual string objects in the memory, but you have the same pointer to the same string.
Okay, is that the case? Any other answers? I'm not asking this question with regards to JavaScript. Just think and answer from whatever the knowledge you have on any other language, because you all have done BScs, right? So you might have a good idea on other languages, and you might have used immutable objects. So you should have a good idea. Primitive types, are they immutable? Isuru might be able to answer this question nicely, so I'll pass the question to Isuru. We have to name people to get the answers.
Right, go ahead. So, immutability, the idea is that like you can use the same, and you don't modify the variable if the process helps with things like thread safety, so that multiple objects can act on the same data because it doesn't change. But in terms of memory, I don't recall why it saves memory.
Yeah, so the main concern in this language is, now if everything is reference type, then what will happen is, say you create an object, a gold object, like session state of the application, where you have all the state related things like username, users, this and that, and application configuration, what is the page state, this and that. You will keep all those in the state object. Then what will happen? then when you go through all these UIs and do operations, this object will grow on and on and on, right? And you will go to one view and do some operations, and you will assign some values to that particular object, and they will be there, and you will navigate to some other particular view, and after some time you might have gone through 5 6 views, and you will have so many things in that particular object, but you never clean it, because for a particular view, say in 3 levels later, then again you use the same object reference, but you won't be using the same set of properties what you had there in the object which you declared to persist the session, but you will still have the same object reference. In that case, what happens is this particular object will grow on and on, but it will never get garbage collected, and this particular memory reference will point to, like, everybody will point to that particular memory reference, and it will grow on and on, and it will be a huge chunk of memory, but you will not need that many information or that many data, whatever the things you have there in all the places. So that is one way of simply explaining what it is, why it saves memory. Because if you have an immutable object, then what you will do is you create an object for that particular instance, for that particular view, do some operations with that, you just get the values, set the values once, and you can't mutate it afterwards. Mutation is you simply create an object, and afterwards you can't do anything on top of that. You can't simply mutate it, change value of a property in that particular object. You create it and you do the operations, you just get the values and do something. If you want to change it, then what you will do is you create a new object with the changed set of values. Then what will happen is that old object will get garbage collected, and the new object will be there in the memory, because we are referring to that object and we are forgetting the old object. Then what will happen is when you navigate through all these UIs, all these views in your application, we will forget the previous state and we will create a new state every time when we want to access the object. And this is one of the key concepts you have to master when you are building large scale applications, uh, because of reference types. It's really nice having reference type and reflection out of the box. All these features are really cool, but they are again evil when you try to build large scale applications, because you will get memory leaks. I myself have whole lot of issues right now. I am addressing several issues like that, and Isuru is like facing them every day, and it's pretty messed up. Like you will come up with you will uh, have no clue how to solve it, because it's all references, and you will again you won't have a single idea about what is keeping this memory reference, what is keeping this object in the memory even after moving to, say, third view or whatever the place. Even like sometimes in the tab you will simply like remove everything, all the DOM content, and you will remove all the, like, you will try to delete the references manually with delete keyword. Then again it will not go away. So hard references, when you have it, it's really hard to like figure out or fix those kind of issues. So this is one cool way of fixing those. But architecturally, you have to think a lot how to apply this. You can't apply this everywhere, and it doesn't, like, I'm not saying that you have to use immutable objects everywhere. You can't do that. You don't do that. But keep in mind this concept is really nice, and object reference, like having reference type objects, is one of the key features in JavaScript, and it is really nice if you use it safely.
What would be like a real world example for when you use
Immutable.
objects?
Yeah, if you have used a framework like React, then you might have come across a whole lot of like people talking about immutable objects, immutable state stores, and persisting state in an immutable store, where you don't reuse the same object, but you forget the previous state and create a new object with the new state. So that is one good example for real world application of immutable objects. Likewise, in any framework, even in Angular, whatever the framework, you can use this. And even if you are building a library, you can use this. And there are a whole lot of libraries which allow you to create immutable objects, like Immutable.js and so on. So, like there might be like really good examples on like why and how you can create and where to actually apply this. But in terms of like whatever the things we use day to day, say if you are using observables, then like throughout observables, whenever you use observable, like if you have used it, like work with observables, it's all immutable. Whenever you transition through each pipe and when you do each operation in a single pipe to another pipe, everything is immutable. So, like when we go into advanced concept explanations and like all the next upcoming topics, we will discuss in detail about this part. But this is the key fundamentals of like how we can create an immutable object natively, and we will discuss in detail on later sessions like why and how.
So we can create the immutable objects in the JavaScript using the following functionalities. The JavaScript provides the both method to use. So we can use the freeze method and the object design method. So after we can pass the object into the freeze method, and the object assign method does something different operation. So let's here is about the object.freeze, and in the let's go to the our code snippet and discuss. We have another puppy object, and we have freeze the object. We freeze the puppy object, and we have tried to assign a 4 for the 4. We have created another property on the puppy object and assign number 4 onto it after freezing the object. What would you think? What was the answer? So you have to keep in mind after the object is frozen, you can't change the values, enumerability, configurability, and writability of the object properties.
Any guesses? As usual, nobody's going to guess, so I'll give you all the answer. You can't create a new property, but what do you think about changing the value of age? Can we do that? Can you? Okay. That is something which I'm not going to answer. Try it out once you have, like, when you get some leisure time. Just.
So, how about if the output is the same puppy object, because it doesn't throw any errors. But if we use the strict keyword, then use the freeze, and after initializing a value onto a new property, it does throw a type error in the strict mode. So you have to keep in mind after frozen the object, the prototype the inheriting prototypes also can't be changed, and you can get the what are the you can get the property values in enumerability, configurability, and writability. What are the contents of those properties using the getTerm property descriptor? Basically, it will tell is the properties contain a value, is enumerability, configurability, and writability. So it's about object copying. So there is two methods of cloning object. One was shallow cloning and another one was called deep cloning. So
this is kind of like a continuation of immutability. What happens is now, if we want to create an immutable object, we have to have a way of creating a new object whenever there is a state change, right? Say we have an object, and give me a moment. Okay, so now this object cloning is one of the key concepts, right? We have to have a way of cloning objects or creating a new object whenever a state change if we want to reach immutability. So if we want to create an immutable object, whenever a state change, we have to have a way of cloning or copying objects. So that is what we are going to discuss here.
So, can you guess is this a shallow clone or something?
Okay, first of all, what is a shallow clone? I didn't hear you. Somebody answers.
Just copies the class
Copies what?
reference.
Copies the reference. Okay. Okay. Any other answers?
Copies the first level properties, like it doesn't copy child. So yeah, it's just yeah.
Okay. Okay. Yeah, it's kind of true but false. Now this one, like what do you think will happen here?
Copy the reference.
And if you try to compare puppy with puppy, shallow puppy, is it a shallow puppy? No. Okay. So if you try to compare puppy with puppy, the shallow puppy, it's not a shallow puppy, FII. And if you try to compare, it is the same reference. So in memory, it will be represented this way. Puppy and shallow puppy refers to the same memory address. So both the objects are in the like there's no thing called like two objects here. Like one object is there and two variables are referring to the same memory reference.
So then what about shallow cloning? So we can use for the shallow cloning, we can use the object design as we previously discussed. So in the code snippet, we have another puppy object, and it have inner object also called vaccinations. So then we have used the object design, and first parameter it get the what was the target object, and the second parameter, and so on. It will takes the source object. So you can provide source object as multiple objects. So after that we will assigning into a shallow puppy constant. So do you guys have any idea about what was the answer when you compare into the puppy object with the shallow puppy and the object inside the puppy object?
Yeah, so we have two console logs. First one, we are comparing the puppy object with the shallow puppy. First one. And the second one, we are comparing this one, vaccination property of puppy object with shallow puppy's vaccinations. So what do you think is the answer?
First one will be false.
Yeah.
Second one will be true.
Okay, okay. So now this is what you call a shallow puppy. So the answer you gave for the previous question, like I asked what is a shallow puppy, right? So what happens is now whenever you create a shallow puppy, what it means is it will create a copy of the source object, whatever you have, and in memory, it will try to use the reference. Now, in this case, whenever you use the assign operator on a primitive value, say a string or number or boolean or whatever, what happens in memory is it will basically copy the value. So, in the very first slides, I explained that whenever you assign a primitive value to another variable, say if you have a string variable and if you try to assign it to another string variable, it copies the value. So in that case, when you use assignment keyword, it will simply copy these values But when it comes to objects, it doesn't copy the value. It copies the reference. So both these objects, whenever you use object assign, they will refer to the same object reference in this case, but they will have different properties. I mean, different memory like allocated for breed and bar. So object assign will work on the first level of the object, where all the properties which are primitive types in that particular target object will get copied, actually copied, but all the non-primitives, say object constructor or string constructor, if you use a string constructor, that again, like whatever the object constructor related things, if, or object literals if you are using, they will refer to the same reference. So keep that in mind whenever you use object assign to create a copy of object. Copying objects is really important because you want to reach immutability, and then again in certain cases you want to create a copy of the object because you don't want to mutate the state of the original object in case if you are say looping through object and doing some operations, and if you don't want to mutate the original object but if you want to create a copy and do that operation, that is one use case like which is which we come across in real world applications, so that you can do with object assign, but it will do this in the root level only. So keep that in mind. All the references which are like all the properties which has object literals, they will not get copied, they will point to the same memory reference. So this diagram explains it in a nice manner, where you have the puppy object, you have the shallow puppy, both of those now, like not like earlier where both of them were pointing to the same memory reference. Now they have two memory references, but the vaccination property in both of these objects are pointing to the same memory reference because we didn't go into that level of copying. So we didn't go into deep and copy all the object descriptors, whatever the properties in nested levels, and create different like properties in memory when we use object assign. So in object assign, this is what's going to happen. You all got the idea, right? Okay, and the next thing is deep cloning. There is no out-of-the-box method available to do the deep cloning where you want to reach this. Say, in the early example, we had a nested property, right, called vaccinations, and if you want to clone that as well, say if you have 10 levels of object nesting and you want to deep clone everything, then you don't have a direct out-of-the-box way of doing it in JavaScript, but this is what you have to reach. And you can do it with, like there are various libraries available to do this. You can use Lodash and so on, but you can simply write your own function to implement deep cloning. One exercise, one thing you can try is try to implement this functionality on your own. Like if you can come up with a code snippet, I will review it and just write the code snippet and see, then you will get a good idea of object referencing, how this cloning works and all the concepts what we discussed so far. You will get a really good idea if you try this deep cloning method, try to implement. Like you can refer all the blogs, this and that, read, then try to implement and bring it when you come to the next session. Then I can go through some of the examples and see what all you have done. And it's not that mandatory for all of you to do it. If you try, if you like to learn and if you like to try out this and see for real what is happening and get a good understanding of this, just try it yourselves.
So that's all about objects, and let's talk about what are the best practices we can follow when we're creating or using the objects. So one thing was don't declare the number, string or boolean value as a constructed method using a function constructor or string constructor or number constructor. Just use as literals. So in the code snippet, we have create a constant called puppy and puppy object. The puppy object is created using a string, using a instance of
String literal.
So yeah. So do you have any idea what was the? We have strictly compare the puppy and the puppy object. So do you guys have any idea about what was the output of this? Yeah, exactly. The output was false because the value of the puppy and the puppy object is same, but the type of the puppy and the puppy object is different because when we come to the puppy object, it is a type of object, type of a string, and the puppy is just a string literal. So, and another thing was don't use new keyword for creating objects, arrays, regex, and functions. So instead of using the new keyword, you can use the literals for all of them. So let's go ahead for the.
This is somewhat like in other languages they say that don't use the constructor. I mean, when it comes to integer, you have simple int and capital I int, right? So people say that okay, don't use the primitive type, don't use that constructor method. So somewhat like that. But keep in mind these are not primitive types.
So and another thing was always use strict comparison when you compare when you do a comparison. So
this we will discuss in a later session on operators. We will discuss in detail on all the operators and what is the difference between triple equal and double equal. You might be confused. Just for the moment think that it is the same thing, but we will discuss in detail later on.
The first thing give us the output as the true, and the second thing was giving the false because of it's strictly comparing the both constants. So how about the object performance factors? So this is kind of thing that Johan has told previously. So we have created a function using a function constructor, and we have used a prototype. In the first function we have a method called puppy method, and it has contained a property called bark, and it will console log a value onto a console. So, and after that we have created puppy object, and we have used console.time for get time duration, and after that we have loop using a I n less than the, we have loop iterate the I 20,000, and we have pushed the puppy method. We have created puppy method instance, not the puppy method, and we have passed it to the puppy object.
So he asked the question beforehand, and I answered I gave the answer. So you all can see that in the first example, what will happen is it will create 200 references of bark function, 2000 references of bark function. But in this case, in the second approach, it will create only one reference of bark when we have it in the prototypes. So that makes a big difference, right? If you are working with Pojo classes, and if you are doing these kind of things, then keep in mind this will be a big performance optimizer.
here is a, comparable output of the both executions. So you can follow the references on the slides, and that's all about the object. And we have next about the prototype session to cover all the how the prototypes is working, and just we have discuss about only the object related for the prototype. In the later session 8, we have discussed in the depth of the prototypes.
Okay, thanks a lot, and thank you, Aravind, for taking up this session. Like he got only 2 days to prepare, so like it was a good job.